Hello, and welcome to this webinar on connecting to APIs in Tableau Desktop. My name is Anya Prosvetova, and I am Tableau DataDev Ambassador and Data Analytics Consultant. Today we're going to look at how to connect to APIs and bring the data from these APIs directly from your dashboard in Tableau using Python and TabPy. I will share some useful resources under the video so you can go and explore the documentation after the session. So what are we going to build today? That's the dashboard that we're going to have by the end of the session. So we are going to connect to REST Countries API that brings data about country when you send the name of this country. Say, for example, you can see on this dashboard, we have the world map, and every time a user clicks on the map, the parameter that I'm using takes the name of the country that's selected and then brings additional details such as capital, country area, and sub-region. And these details are not contained in my original dataset. Here I'm using just the standard world indicators dataset coming directly from Tableau. So that's what we're going to build by the end of today. But first, let's have a very quick intro to APIs in case you have never worked with them. So what is an API? API stands for Application Programming Interface, and it allows two pieces of software talk to each other and exchange information, exchange data when a user sends a request. So imagine you have a mobile phone, for example, and you have an app on this phone where you check the weather. So that's going to be your client application. You go on the weather app. You say, I want to see the weather in next 3 days in London, for example. You send the request to the REST API. You don't think about it this way, but that's what happens in the background. You send your request via the API. It gets to the server where the weather data is stored. The server finds the data that you are looking for and sends the response back. And that's visualized in a nice way in your client application, in your app. But in general, the response from the API comes usually in two formats. Either it's JSON or XML. In our case, we're going to work with the REST API, the type of an API, and the response will come in JSON format. So just to explain a little bit more, XML stands for Extensible Markup Language and JSON for JavaScript Object Notation. And as I said, we're going to work with JSON response, and JSON comes in the pairs of name and value. So all the data you will get back will be stored in these pairs where you have the name, say a type of the data. In this case, for example, it's capital for the country that we sent the request for. And then the value is for this particular country. What's the capital for this country? So that's going to be our name, capital in this case, and value, Bogota in this case, because we sent the request to get details about Colombia. So that's the response from the API that we're going to look at in this session. And that's the APIs. Now let's have a look at what TabPy is. And TabPy is a server, is a framework that Tableau designed to allow Tableau communicate with Python and run Python scripts inside Tableau dashboards. You can also run Python scripts using TabPy in Tableau prep flows, similar like you would do in calculations in Tableau Desktop. But that's a story for another session. So let's now look at how you can build your calculations in Tableau to use Python scripts and how you can structure them. First of all, you're going to create just a normal calculated field and use one of 4 functions available. And these 4 functions that are on the screen now are used depending on what you're going to return from your script. Say, if you're writing a script that will return some numbers, for example, integers, you would need to use script int function. If you're going to return a text, a string, then you're going to use a script _str. So these are 4 functions that are available for you in Tableau. And they all operate as table calculations. So all the things you will know and apply when you work with table calculations will be fair when you work with script functions as well. And that's a little bit of a sneak peek of the calculation that we're going to write today. And this calculation, for example, is going to bring us the capital of the country from this API. Capital is going to be a text, hence we're using a script underscore str function in this example. And you can see that the dashboard is based on the map of the world, and what the value that's passed to the API is the name of the selected country. So you can see that's ATTR selected country at the bottom of my calculated field. That's the value that's going to be passed. To tell Tableau where this value should go in your script just above, you will need to use underscore arg. In my case, it's just one, but you can have as many as you would like. These arguments, there is no limit on how many arguments you can have. But the idea is that you use this underscore arg and then the number in your script to signify where you want to put the certain value from a certain field in your Tableau workbook, and then these values are going to be taken in and replace the placeholders in your script. And always remember, when you're working with script functions in Tableau, to make sure to include the return statement at the end of your script. So you make sure that Tableau understands what's going to be returned, and that's going to be just one value that's going to be returned from the script. So unfortunately, at the moment, you can't return, for example, a data frame, a table with values. It's just going to be always one value. And as I mentioned earlier, script functions operate as table calculations, and so Tableau expects the script to return a single column that has either a single row or the same number of rows as it's passed to TabPy. Say, for example, if you have a table in the view with 15 rows, you will be returning 15 values, one for every row, when you pass a certain value in via the script function. So that's how these functions operate in Tableau. You can also, you need to also remember that you need to aggregate the data before sending it to TabPy. That's why I'm using ATTR function here for my string field. It's not a number, so it just needs to have an aggregation. In this case, it's ATTR. But if you are passing the numerical values, then you need to make sure that you are setting the correct aggregation, say sum or average, for example. In my example, as you see on the screen, I'm just passing one value, selected country. But you can pass as many values as you want, as many different arguments, and they can be a mix of strings and numbers, so depending on your script. So let's see how we can build this dashboard in Tableau and connect Tableau to API and bring new values into our view. But before we go into Tableau, I would like to show you how I built and tested the Python script that I'm going to use later in Tableau Desktop, so you can see how you can also test it before using it in Tableau. I would always recommend to test Python scripts outside of Tableau, just to make sure that you're getting the values that you want and the script itself works fine. So that's the API that we're going to connect to. And with any new API you're going to work with, make sure that you start with reading documentation, because different APIs work in a different way. This API, for example, is quite straightforward. It doesn't require authentication or any payments. But if you're working with more complex APIs or maybe private APIs, do make sure that you check how to connect and send the request and how to structure your request. And that's my Jupyter notebook, where I was testing and playing around with the code and made sure that it works before I put it into Tableau. So we need to see first what we need, which libraries do we need to connect to the API. So for that, we would need the library that's called import. So that's the first thing that I'm doing here on line 1. I'm starting with importing this requests library. Once I do that, I create a new variable that's called country on line 5. In this case, I set the value to be Italy, but this is just the placeholder, the variable that's going to change once I send different requests. And that's the variable that we're going to use as well in Tableau to pick up the value from our parameter and send it via the API. So once I have this variable country, I then create the new variable on line 7 that's called URL. And that's our URL, the request that we're going to send to the API. And you can see that the URL is going to be static, but the only dynamic part is going to be this very last bit, which will take the value from our country variable that we defined just above. And then we also check that our request is sent, it's received, and the API is up and running and ready to send the response to our requests. So if I run this cell, I will get the response 200. And this is a very good sign, because when you work with APIs, you want to make sure that your response comes as a 200 with the 200 code, because that means that the request is correctly structured, it's sent fine, it received the response from the API, that it's online and available for you to query. So that's a very good start. Then we need to get the response in JSON format. So let me run this second cell. And you can see that we are getting this big JSON response with all the details about the country we sent, this Italy in this case. And we can see that it brings us all the details about the region, the sub-region, the capital, languages, all these different things in all different languages. So that's great. So that's useful to see how your response is actually structured, to understand how you can unpick it and get the details that you are actually looking for. So let's find, we were looking at the capital first, and this is it, capital Rome. And now I want to take this value, the value Rome, out of this JSON response. So that's my last cell in this case. And let me change to return capital at the end. But you can see, because I was testing for 3 different variables that I want to bring in Tableau Desktop, capital, area, and sub-region, I have the variables, for all these 3 values. So if I want to return capital, let's run this cell, and you can see I'm getting back Rome. That's very nice. Let's see if area works. Let's rerun the cell. And we can see that the value for the area, let's see. And we can see that the value for the area is coming back correctly. And just to make sure that we are getting correct value for the 3rd variable, sub-region, let's rerun. And we can see that it's Southern Europe. Let's find the sub-region, I think it was at the top, yeah. So you can see that sub-region value is coming back correctly as well. So we see that our code in Python, for now outside of Tableau, works fine. The values are coming back correctly, so we are ready now to take it and move it into Tableau Desktop and adapt it a little bit so it works in our Tableau Desktop. So let me go to Tableau Desktop. Once we start building the calculated fields using script functions, because Tableau wants to run these calculations, if you don't have the connection between Tableau Desktop and TabPy enabled, you will keep getting errors that Tableau will tell you, I can't run these calculations, you don't have the connection established. So let's maybe set up the connection first, so we won't get these errors while we build it. So To use TabPy in Tableau Desktop, you need to have TabPy installed. Always recommended to install it on a separate server, not on the same server that you have your Tableau server, for example, installed. It can be installed in the cloud, it can be installed on some hardware, but the main thing is that you need to install it and make sure that it's always available. So say, for example, if I publish this dashboard onto my Tableau server, I want my users to be able to access it and interact with it and get the data that I want them to get at any time. So you need to make sure that TabPy is running on your server all the time, is always available. That's the first thing. For this particular use case, for this demo, I'm running TabPy. I have installed and running TabPy on my local machine. So that's going to be quite straightforward to connect. And that's why I need to launch it first. I need to start the TabPy because at the moment it's not running. So even if I make the connection in Tableau Desktop, I won't be able to run my calculations because the server actually is not running. So if you have TabPy installed, for example, as I do here on my local machine, if you have it on a separate server, you don't need to do anything. If you have it on local machine, you just need to open the prompt, the Anaconda prompt I'm using in this case, type TabPy and press enter. And once the server is up and running, you will see this note at the very end of the response saying web service listening on port 9004. Once you see this note, you know that your server is up and running and you're now able to use it in Tableau Desktop and use script functions in your calculations. Remember this number 9004, we will need it in a second when we're going to connect to TabPy from Tableau Desktop. So to do that, we would need to go to Help at the top of the window of your Tableau Desktop, click on Settings and Performance, and then Manage Analytics Extension Connection. Once we go there, we will see all the options that are available for us. We can see that we can connect to TabPy, we can connect to Einstein Discovery, and we can also connect to rserve. That's the same, or rather that's a similar thing as TabPy, but just to run R scripts. So you can run R scripts as well in Tableau Desktop. If you want to run scripts or use different programming languages in Tableau, you can build your own analytics extension using the Analytics Extensions API that's provided by Tableau. And you can then use this extension and write calculations in a different language rather than Python or R, and run maybe some particular custom models or custom scripts inside your Tableau Desktop. We are going to go the easy way this time, and we're going to connect to TabPy. So I click TabPy, and you can see that here I need to put the host name, I need to put the port, and if I have, username and password. I didn't set any username and password, but you can obviously configure your TabPy installation in any way you would like, including setting up username and password, and I obviously recommend to do that if you want to use it in production. So host name in my case, because I'm running it on my local machine, is going to be localhost, and the port is going to be 9004, exactly the same one that we saw when our TabPy was launched. So that's why I was saying, remember this number. Again, this number can be configured. You can use a different port if you want to, but this is the one that's used by default. So let's see if we can test the connection, and we get the successfully connected message. That's really nice. So now we are ready to go and build our calculations. Let's click Save, and then just close this window. Nothing changed for now, but we now start building our calculations, and we will see that they will work as we expect them to be. Now, let's find, I already created an empty calculated field. That's just called capital. And so let's start building our calculation. So the capital calculation is going to return the string, the word for the capital of a selected country. So we will need to use the script str function because it's going to return a string. Okay, gives us 2 parentheses. Let's just make some space because we need this space to put our Python script inside. The whole Python script will go inside this function. So make sure that you remember to put the quotation marks around it. Oops. And now we are going to write our Python script here. I will cheat a little bit and I will copy the one that I already have. That's the same one that we just saw earlier in Jupyter Notebooks. So let's see. We have our script function, we have quotation marks, we have, let me use the single quotation mark because I have double inside already. We have import of our library, import requests. We defined our variable, that's country, and you can see that I have already replaced the country that we had hard-coded in Jupyter Notebooks for testing with this underscore arg1. And that's what I was referring to in one of the slides earlier, that this is going to be a placeholder for the field, for the value from the field that we're going to set just after this script. So remember about this argument here. And then the rest is basically the same script as we saw just now in Jupyter Notebooks. We have our URL, we get the response, we parse it to get the capital out of it. And then we didn't have it in Python script earlier, but make sure that you always include, that you always return the value that you want to show in your view, in your table or in your dashboard. So we're here returning the variable that's called capital that holds the value for our capital. Okay, so we have that, and then we need to specify what's this argument 1, which field that we're going to use that's going to go into this argument 1. So just put the comma, and we need to put the field that's going to be, in my case, selected country. And I will wrap it in a ttr function. Okay, we see the calculation is valid. All looks okay. So let's press OK. Now you can see that we are not getting the exclamation mark. The calculation looks fine. So let's now bring it onto the rows. And it seems like it works. You can see in my parameter, selected country, that's where the value is coming from. We can see that currently United States is selected and the capital for United States is Washington, D.C. So it looks like it works. And we can also notice that once we brought the capital field into the view, we have this triangle next to it that always signifies that this field acts as a table calculation. So if I click on this triangle, I can see the same option as you can see for the table calculations. You can choose how you want to compute this calculation, and you can also edit the calculation. Mostly in this case for choosing how you want to compute it, because you can't set a different type of calculation. In our case, it's a very simple table. It's just going to be 1 row and 3 values. So setting it to compute, if I go back, table across, that works absolutely fine for us. If you have a larger table and you want to make sure that it computes based on a certain field, make sure that this field is in the view. So if I bring the selected country and drop it on the detail, exactly like you work with table calculations, I can select it now in compute using, and that will fix my calculation on this field. And every time Tableau will look at this field and understand that that's what it should use for computing. In our case, the value didn't change because, again, as I said, we just have 1 row here. Okay, great. So let's now build another calculation that's very similar, and that's going to be the sub-region calculation. Again, subregion is going to bring us the name of this subregion. So it's going to be a string again. So let's select script string, get some space, get some quotation marks for our script. And I will do the same. I will just copy the Python code that I already have. So the same here, we import the library, we create the variable country, and then we use it to build our URL. It's just slightly different here because we are getting not the capital value, but the subregion. But as in the previous calculation, I'm returning subregion here. So make sure that you don't forget to add this at the end of your script. And again, after the script is done, after the quotation mark is closing the script, I just need to specify the field that's going to be passed as the argument one. So in my case, it's selected country. That should work. Let me just put it here so it's a little bit easier to understand. Okay, we see that the calculation is valid. The calculation will return the value of subregion. So let's see what happens when we bring it into the view. I drop it on the rows, and we can see that we get in the value of North America. That's exactly where United States are, so seems like it's working fine. And again, we can see that we're getting this triangle next to the subregion, so that means that it's also a table calculation. And the last field that I wanted to create is the country area. And that's a slightly different formula, slightly different syntaxes, because this calculation will bring back a number, and it's going to bring back a float. And in other words, a number with digits after decimal point. So we would need to use not the script string, but script real. That's the one to bring the float values back into your view. So script, we need to add quotation marks, and then add our code as well. And it's again very similar code. It's just the difference is that it returns back the area of the country rather than the subregion or the capital. So make sure that we have the return statement. Okay, and then we just need to specify the same field that we have been passing to all other three calculations. It's going to be a selected country. And let me aggregate it. Okay, another calculation that's valid. And you see that in this case, it's quite straightforward. We're using the same basically script, just changing what we're going to bring back. So let's click OK and bring it into the view as well. And here we go. You can see that we get the value for the country area. Make it a little bit wider so we can see the complete name of the column. But here it is. You can see that we brought these three fields into the view, and we now have this nice table that shows us additional details about the country. And you can see that here we have a simple table with just three values that are coming back from this API. But if you want to bring more values from an API, or somehow run more calculations using Python scripts, you would need to create one calculation for the value that you want to bring, or rather for the type of value that you want to bring. Say, if you want to calculate 5 different measures, you would need to create 5 different calculations, separate calculations, that run the script inside and bring you one of these 5 measures. And then you can bring them together in the view like I did here, and that will build your table. So that's a little bit inconvenient at the moment. You can't bring the whole table with several values at the same time using this approach, using Python scripts in calculated fields. But if we go to our world map, because I'm using a parameter here, the selected country is my parameter, I set up, if I go into dashboard and actions, I set up a dashboard actions that's a parameter action, and that just changes my parameter selected country every time the user clicks on the map, on a country on a map. Okay, so let's test it. We have now United States. If I click on Australia, that should bring me details about Australia. Indeed, let's make it just a little bit bigger. If I click on Chad, I'll get details about this country, and so on and so forth. So you can see that now we are basically sending the request to the API and getting the response directly from our dashboard. The end user don't need to know how it works in the background, but you can see that it was quite straightforward to set this up, and once you figured out the code, it's quite an easy exercise to make it work. The only thing I want to mention here is make sure that you URL encode all the values that you're going to pass to the Python script using TabPy. Because, for example, when I was building it, it was working fine, but when I had countries like United States, the countries where you have a space in the name, it wasn't taking it correctly, and I was just getting an error. So it was working fine outside in just Jupyter Notebook, but it wasn't working in Tableau, because Tableau wasn't able to pass this space in the value. So to fix this, you would need to replace the space that you have. In this case, it's my parameter. So you need to replace the space with %20. That's what's used to signify the code that's used to signify space in URLs. So just make sure that you remember this thing, and that might cause some errors if you're passing string values. But with numbers, it obviously should be fine. So that's how you can build this simple dashboard. That's how you can connect to APIs directly from your Tableau desktop. And as I said earlier, you can publish this dashboard onto a Tableau server or Tableau Online, set up connection to your TabPy server on your Tableau server or Tableau Online, and then your end users will be able to use and benefit from these Python scripts in dashboards straight away without any additional installations or setup on their side. And here are some useful materials, some useful references for learning more about Tableau and Python, and the links will be shared under this video. Do go and read the TabPy documentation to understand how to deploy it and how to configure different options. There is this really good blog about TabPy configuration and security as well. And there are several nice articles from Tableau about different examples of how you can use TabPy in your Tableau desktop. And obviously, if you're not a member of the Tableau developer program, I would really encourage you to join, because it provides you with a safe sandbox Tableau Online environment where you can develop your projects, play around with different APIs, and learn how to work with them without worrying that you break something. It also gives you a lot of different resources and support in learning all these different tools, and a great community where you can go and ask questions, and most likely someone worked with a similar issue and they will be able to help. So really great environment and great community, so I would encourage you to join if you're interested in learning more about Tableau APIs and developer tools. So this is it. Thank you for joining me today, and I hope this session gave you a good understanding of how you can use Python and TabPy in your Tableau desktop, in this case connecting to APIs, but you can also use it to run some machine learning models or other complex statistical calculations that are not available at the moment directly in Tableau. Thank you again for joining me today, and do subscribe to our channel if you haven't yet, and check out other videos we have. And please send us your questions and comments under the video, and we'll get back to you shortly. Thank you. Have a good day.